In this lesson, we're going to look at properties of real numbers. There's a lot of unique properties that happen when you're dealing with numbers, certain things that you can do, and you're probably well aware of these, you just did not know that they had names. So the first problem, two expressions that have the same value for all allowable replacements are called equivalent. The statement 3 plus x equals x plus 3 illustrates a commutative law. That's just kind of a switching, and that works with adding and multiplying. 3, the statement 2p times q is the same as 2 times pq illustrates an associative law. That's what I call a grouping law. Again, when you're multiplying and adding, you can group them any way that you want, and you'll still get the same answer. Number 4, the statement 5 times the quantity a plus b is the same thing as 5a plus 5b. That illustrates the distributive law. You may notice that the number 5 was distributed to everything in the parentheses. Number 5, the terms of an expression are separated by addition or subtraction signs. We typically see problems that have two terms, but sometimes they do have more than that. To factor an expression, we find an equivalent expression that is a product. So if I said factor 15, you could say 3 times 5, because 3 times 5 equals 15. And like terms have exactly the same variable factors. Like terms have exactly the same variable factors. So if two terms both have an x in them, then they're considered to be like terms. So write equivalent expression, use a commutative law. Now commutative just means a switching. So an equivalent expression to t plus 5 would be 5 plus t. It's just switching the two terms around. Likewise, we could say 18 plus xy is the same thing as xy plus 18. And again, this works with adding and multiplying, not dividing and subtracting, so you have to be careful with those. Number 14, use the associative law. This is where you're going to group them differently. So just like these were equivalent, an equivalent expression here, maybe we want to group the 3 plus x together and then the y. And then on the next one, 7 and a are already grouped together. Well, let's put 7 on the outside and a and b together. You'll still get the same result. Those are equivalent. This is using the distributive, and I know that because I have a number sitting outside of a set of parentheses. So I can take that number on the outside and distribute it to everything on the inside. And on this one, I would actually have to distribute it to 3 terms. Here it's 2 terms, and here it's 2 terms. So let's look at this long one first. So if I take 5 and distribute it throughout, 5 times x, and whenever you have a number next to a parenthesis, that means to multiply. Even though there's not a multiplication symbol there, the parenthesis acts as multiplication symbol. So 5 times x is simply 5x. 5 times a positive 7, I know that's a positive 7 because it's plus 7, is a positive 35. And 5 times a positive 2n is a positive 10n. And that's my final answer. I just used the distributive property. So let's look at this next one. 11 times p is 11p. 11 times negative 3, that's a negative because it's a minus, is going to give me a negative 33, or a minus 33. So that's how distributive property works. Be careful of your signs. That's probably the number one thing I see students do incorrectly, so just be aware of your signs. Now factor, check by multiplying. This is reverse distributive, if you want to think of it that way. Reverse distributive. In other words, something was distributed to both of the terms. So if I see 3x plus 18, what do they have in common? Well, 3x and 18, they have a 3 in common. So we're going to put a 3 outside next to parentheses. And 3 times what is 3x? Well, x. Because if I distribute this, I will get 3x. So 3 times what gives me 18? Well, that would be a positive 6. So that's an example of factoring. So what does 12 and 30 have in common? Well, let's see here. 6, I believe, I think is the largest one that goes into both. So if we factor out a 6, 6 times what is 12y? Well, that would be 2y. And 6 times what is 30z? Well, that would be 5z. So that's my factored form. Again, it's just a reverse distributive. And finally, collecting like terms. You can only put terms together if they're like terms. So the first one, 14x minus x, those are definitely like terms because they both have x's. The tricky part is this is really a 1x. So 14x minus 1x would be 13x. 8t minus 11t would be a negative 3t. 8 minus 11 is 3, and they both have the t. Let's skip down to 35. Like terms, I see numbers, so I'm going to go and just put boxes around all my numbers. Notice I'm including the signs. Every number has a sign, it's just the number or the sign right in front of it. And then I have terms that have C's in them. So I'm going to group all of my numbers together. So I have 16, negative 20, and 6. So let's see here. That's going to give me negative 4 plus 6, which gives me 2. And then when I look at my C's, I have negative 40, negative 5, and 8. So negative 40, negative 5, that's negative 45 plus 8. So that's going to be, signs are different, subtract. So negative 47. Does that sound correct? And as soon as I said that, I realized it wasn't 47, it was 37. I had my ones digit correct. So, what's my final answer? Well, 2 minus 37c would be my final answer. Or you could have written 2 or negative 37c plus 2. That would work as well.